Let's try another problem. Let f of x equal to 1 plus mod sin x to the power of a by mod sin x if x lies between minus pi by 6 to 0, and the functional value is b when x is 0, and it is e to the power of tan 2x by tan 3x if x is between 0 to pi by 6. Now see the condition given on the function. The values of a and b are required, and how is the function? The function is continuous at x equal to 0. So satisfying this condition that it is continuous at x equal to 0, we are supposed to find the values of a and b. It's predefined that the function is continuous. Now let's recollect, when do we say a function is continuous? Because here the function is defined separately on the left side of 0 and on the right side of 0. The function should satisfy limit x tends to 0 minus f of x must be equal to limit x tends to 0 plus f of x, and these two values must be equal to f of 0 value. So let's calculate each of these limits and then equate them so that we create equations in terms of a and b to get their values. First I am calculating limit x tends to 0 minus f of x. How is the function f of x defined? Into the 0 minus domain, that is a value which is less than 0. The function is defined as limit x tends to 0 minus 1 plus mod sin x whole raised to the power a by mod sin x. What happens if I directly substitute and verify? Sin x when x is 0 is 0. So this is 1 plus 0, that is 1 to the power of a by 0. That gives me 1 power infinity form. Now do you recollect what do we do when we got a limit in the form 1 to the power of infinity? Correct. By using Euler's formula. What does Euler's formula says? This same limit must be equal to e to the power of limit x tends to 0 minus, now 1 plus f of x raised to the power of g of x. So how will be the limit? Mod sin x into g of x, that is a by mod sin x, that is e to the power of limit x tends to 0 minus mod sin x, and mod sin x gets cancelled and leaving me with a as a constant number. So what is the limit? The limit is e power a. So what we did, we calculated limit x tends to 0 minus f of x, and the limit is coming to be e power a. We'll be using it while forming equation for a and b. Let's continue with the right hand limit. How is limit x tends to 0 plus f of x? How is the function defined to the right side of 0? The function is e to the power of tan 2x by tan 3x. Now how do we evaluate this limit? The limit will go into the tan function, exponential function, and it becomes e to the power of limit x tends to 0 tan 2x by tan 3x. Now both are tan functions only. So simply we need to convert them to standard trigonometric limits. That is limit x tends to 0 tan 2x by 2x times 2x into 3x by tan 3x into 1 by 3x. Now this additional x gets cancelled. The rest of them all are in the standard form only. So this gives me e to the power of 1 into 2 into 1 into 1 by 3. That gives us e to the power of 2 by 3. We have calculated the value of limit x tends to 0 plus. Now let's go back to finding the value of f of 0. F of 0 value is given directly by definition itself, and the value is given to be b. Now again let us recollect the condition. For continuity, f of 0 must be equal to limit x tends to 0 minus f of x must be equal to limit x tends to 0 plus f of x. If this condition is satisfied, then only the function would be continuous at x equal to 0, right? Now, what is f of 0 value? B must be equal to limit x tends to 0 minus, which we calculated, e to the power of a must be equal to 0 plus f of x limit, e to the power of 2 by 3. Now, if you look at this equation, can we get the values of a and b from this? Can we get the values of a and b from this? When I equate these two, I get A value as 2 by 3 and directly equating these two would give me the B value as e to the power of 2 by 3. So A is 2 by 3 and B is e to the power of 2 by 3. Which option these values are satisfying for A and B? That is option given at B for this, right? Let's continue with another problem. In order that the function f of x is x plus 1 to the power of cot x is continuous at x equal to 0, f of 0 must be defined as. So what is required here? We are supposed to find f of 0 value. But by definition of continuity, because the function is said to be continuous at x equal to 0, f of 0 must be equal to limit x tends to 0 f of x. So let's calculate this limit x tends to 0 f of x. That is the limit of limit x tends to 0. What is function? 1 plus x whole to the power of cot x. What happens when I directly substitute the value on this? X tends to 0, it is 1, cot 0 undefined, so it's in 1 power infinity form, right? Now again, when we come across a limit which is in 1 power infinity form, can we take help from Euler's formula? What does Euler's form says? The same limit should be equal to e to the power of limit x tends to 0. Now 1 plus f of x whole to the power of g of x. So it should be f of x into g of x. How do we evaluate this limit? This is a standard trigonometric limit. Limit x tends to 0, x by tan x. This is e to the power of 1, that is e. So what is f of 0 value coming? F of 0 value is e, so that the function is continuous at the point. So which option is this satisfying? The option given is f of 0 must be e, that is at the option C for us. Let's see one more problem on this. The function f of x equal to x if x is rational and it is 1 minus x if x is irrational, then f of x is continuous at how many points? Is it continuous at infinite points, or is it continuous at only 1 point, or is it continuous at 0, right? Now this is quite a trivial case, but first let us define continuity. If I take any rational number, say x is a rational number, then we have a property that to the left of x there are infinitely many irrational numbers are there, and to the right of this number there are infinitely many irrational numbers are there. Similarly, if I consider x as an irrational number, then to the left of the irrational number there are infinitely many rationals, and to the right of it there are infinitely many rational numbers. Do you remember the properties of real numbers? Now, if I use these conditions, then at some x equal to a, which is a rational, I am trying to evaluate the limit. Then shall I say limit x tends to a minus f of x does not exist. Now why it does not exist? Because to the left of a rational number there are infinitely many irrational numbers. So there is no continuity in the domain. Therefore the function is not continuous at any x which is rational. Isn't it? So the function is not continuous at any of the rational numbers. This is confirmed. Now let's try what happens if x is a irrational number. At some x equal to a which is irrational. Now here also limit x tends to a f of x will again does not exist, because when I try to calculate the left hand limit at an irrational number, there are infinitely many rational numbers. So the domain is not continuous here. Similarly, when I try to calculate limit x tends to a plus, there are infinitely many rational numbers on the path. So right hand approximation cannot be evaluated. The left hand approximation cannot be evaluated. Therefore, limit does not exist. If limit does not exist, shall we conclude the function is not continuous at any x which is irrational. So at no rational number and at no irrational number, this function is continuous. So at how many points is the function continuous? At 0 points. So which option is it satisfying for us? The option satisfied is C, because here the limit itself could not be evaluated, right? So this is a discontinuous function, non-removable discontinuity, or something called essential discontinuity. This is what we call when the limit does not exist, then it is essential discontinuity. Now let's check a problem on composite functions continuity. The points of discontinuity of y equal to 1 by u square plus u minus 2, where the function u is defined as 1 by x minus 1 are which of them, right? Now if you look at this function here, y is a function of u, where u is a function of x. So if I treat u as some g of x, now how is your standard function defined? Y is f of g of x, that is f circle g of x, isn't it? If you recollect the condition for continuity of a composite function, this g must be continuous at x equal to a, and this f must be continuous at x equal to g of a. Then the total function would be continuous. So first let us verify g's continuity. U equal to 1 by x minus 1 is obviously not defined when x equal to 1, isn't it? Here x cannot be equal to 1. When the function is not defined at x equal to 1, shall I say it is obviously discontinuous at x equal to 1. So u is discontinuous at x equal to 1. The inner function itself is discontinuous at x equal to 1. Therefore, the y function, which is f of u, is discontinuous at x equal to 1. This is already an observed point of discontinuity, right? Now let's further proceed. Not only at x equal to a it is continuous, it should also be continuous at g of a. So let us first verify where is this function y becomes discontinuous. Where is the function y equal to 1 by u square plus u minus 2 is discontinuous. If I rewrite the denominator as u plus 2 into u minus 1, then shall we say u cannot be equal to minus 2 or 1. So what happens now? Y is discontinuous at u is minus 2 and u is plus 1. But u is not the domain for us. For u, that is 1 by x minus 1 is equal to minus 2 and 1 by x minus 1 is plus 1. At these 2 points, the function is discontinuous, y is discontinuous. Let's verify where are these 2 conditions satisfied. First, when 1 by x minus 1 is minus 2, can we write x minus 1 as minus 1 by 2 so that my x value becomes half. So when x equal to half, the function y equal to f of u is discontinuous at x equal to half. So this is another identified point of discontinuity. Similarly, when 1 by x minus 1 becomes 1, then also the function is discontinuous. Then x minus 1 is 1 or your x value becomes 2. So again y equal to f of u is discontinuous at x equal to 2 also. So what are the different points of discontinuity values for x that we identified? X was discontinuous when x is 2. Similarly, the function was discontinuous when x is half, and we also observed that it is discontinuous when x is 1. So what are the different points of discontinuity? X equal to 2, x equal to half and x equal to 1. These are the points of discontinuity of the function. Therefore, which option does give us the values 1, 2 and half? That is option given at A. When x is 2, when x is 1 and x is half, the function becomes discontinuous. Right kids? So we have seen composite functions discontinuity in this problem. Right. Thank you. We'll meet in the next lectures.